You wait a while for the rest. I don't know why it will kick me out. I didn't do anything, you know, like I just like talk, then suddenly close. Yeah, I think the second time happening. So this is the real wow. Okay. I still got other video can show on Redox. No, not bad.
The reason why.
Sorry. We watch a video while we wait for the rest. This one they will talk about, just now I roughly see. This one they will talk about like the oxidation state part. Okay, so we just listen for a while.
And what they're willing to do to get it. Electrons are what make it possible for an atom to bond with other atoms to form molecules, and when that happens, a tremendous amount of energy can be exchanged in the process. Not all chemical reactions involve electrons changing hands. Acid-base reactions, you'll recall, are more about swapping protons. But because electrons are the real coin of the realm in chemistry, the most important reactions that take place on Earth involve the transfer of one or more electrons from one atom to another. These are redox reactions. Redox, which is a portmanteau of reduction oxidation. For what is actually happening in redox reactions, but we are stuck with them. Reduction is when a substance gains electrons. Yes, it gains, which is the opposite of what the word reduce means. Fantastic. And yes, sometimes I want to punish the people who named these things so inaccurately, but they didn't know any better and they're all dead, so we can't do anything about it. Protochemists would make pure metals by heating or smelting their ores. And they noticed during the smelting that these substances would become lighter. So I guess it's not crazy that they decided to say that these substances were being reduced. Our old French friend Antoine Lavoisier figured out that this was because oxygen gas was actually leaving the compound, making it lighter. What he didn't know was the actual chemistry involved. Oxygen is unsurprisingly the quintessential oxidizer. It pulls electrons off of one molecule to make itself more stable. But if you heat it up enough, it gets all energetic. Today, we understand that oxidation and reduction are all about electron transfer. So you might think that we'd rename them, and some chemists have tried producing terms like electronation and de-electronation. But once a set of terms is decided upon and used for a while, it's pretty difficult to uncreate it. So we're stuck. To keep these seemingly nonsensical names straight, I rely on the phrase oil rig. Oxidation is loss of electrons, reduction is gain of electrons. We just gotta know this stuff, because it's everywhere. When your cells convert sugar into energy so you can move and breathe and think, that's redox. When plants photosynthesize sunlight into food, that's redox. The battery powering your laptop, redox. Fire, also redox. Since electron swapping is the name of the game here, when you study redox reactions, it's important, critical, absolutely essential to keep track of the electrons. Think of them as dollars or pesos or pounds or euros. In any transaction, one person is going to gain them and the other is going to lose them. And to stay on top of things, you have to keep tabs on who's ahead and who's behind. Atoms are fond of sharing covalent bonds and the sharing of electrons. The processes are easier to follow if we imagine that the atoms are already splitting up the bank account as if they were in an ionic or non-sharing bond. So an atom's oxidation number is basically what its charge would be if it actually owned all of its electrons exclusively, like the newly minted bachelors that they may become. So to figure out those oxidation states or oxidation numbers, we have some simple rules for some atoms. First, the oxidation number for any element by itself, whether it's monatomic or diatomic or polyatomic, like an atom of calcium, or a molecule of H2, or an even bigger molecule of sulfur S8, the oxidation number is 0. Atoms, by definition, do not have a charge. If they had a charge, they would be ions, and if they're sharing with themselves, they share equally. Second, for a monatomic ion, basically a charged atom, it's simply the size or number of its charge. So the iron 2 in Fe2+ has an oxidation state of +2, while a chloride ion is -1. Third, oxygen, which is unsurprisingly all over redox chemistry, almost always has an oxidation of -2, unless it happens to be in a peroxide molecule like hydrogen peroxide. Fourth, hydrogen is +1, and fifth, fluorine is -1, as are all the other halogens most of the time. Pretty much unless they're bonded to fluorine or oxygen, because fluorine and oxygen are so bad that they can make anybody's oxygen.
Yeah, so they got mentioned already. So just now they say for elements, right, the oxidation state is 0. Then for those that are in ions, right, just follow the charge of the ions. Okay, then for oxygen in a compound, okay, if oxygen is on its own, right, then it's 0, but oxygen in a compound is -2. Then for hydrogen, most of the time is +1, okay. So that's like the few standard rules, so-called. Okay, so this one need to memorize. I think I stopped here, right, then suddenly stop the Zoom meeting. Okay, so now, right, we can go to the worksheet first. Okay, so this is the worksheet. Okay, chemical reaction 2. Okay, so let's see the question. Okay, so here they say draw the dot and cross diagram for the hydrogen peroxide. Okay, show only the valence electron. So can you do this first? I don't know why the rest never join. Okay, hydrogen peroxide. Hydrogen peroxide is this one, H2O2. Okay, can you try first? NNSO4. Sorry, I'm looking at the pages. Wow, okay. Okay, for the dot and cross diagram for the hydrogen peroxide, right, it will look like this. Okay, I share with you. Okay, it will look something like this. Okay. Okay. Okay, I don't need this. Can see, right? It's this one. Okay. So H2O2, so you go count, right? Hydrogen there's 2, so balance. Hydrogen there's 2 balance. Then oxygen, right, around it have 8. So around it have 8. Yeah, so this one is correct one. Okay, so this is the answer for the first part. Okay, I stay here for a while. Then you can copy if you are wrong. Okay, then in a while I will switch back. Okay, I switch back now. So go back to here. Okay, state the oxidation state of Mn in MnSO4. Okay, how to do this, right, is for SO4, right? SO4 is a ion, is a sulfate ion. This one here is a sulfate ion. Okay, sulfate ion, right, the charge is SO4 2 minus. So in order for it to be a compound, right, your Mn must be Mn 2 plus, correct? So these two, they will balance each other. Mn 2 plus, SO4 2 minus, so 2 plus 2 minus, so balance, so become Mn SO4. So the oxidation state of Mn, right, will be plus 2. Okay, so I type out, so I write the oxidation state of Mn is plus 2 in MnSO4. I can subscript. Okay, can. Okay, so it's like that. Then when we write oxidation state, right, usually we put the sign first, then we put the number, so it's plus 2. But when we write down in the formula, right, we write 2 plus. Okay, so just take note of the difference. Okay. Okay, then for part C, part 1, how could you tell that hydrogen peroxide acts as a reducing agent in reaction 2, okay, from the chemical equation? Explain your answer. Okay, for this one, right, there's a few ways you can say. Reducing agent means it is wait, let me write down. Reducing agent means it is self-oxidized. That means, yeah, let me write down. Okay, reducing agent, let me highlight first. Reducing agent means, okay, it reduces other, but self-oxidized, okay? So if you look at this one, how should I write down? Self-oxidized, okay, so reaction 2, so he's talking about this one. Okay, let me highlight, so they're talking about this one. Then you look over here, here is H2O, right? Okay, we zoom in. this one. So let's write down the oxidation state, okay? So for hydrogen, right? Okay, I go back to the notes for a while, so that I can show you where is it. Later you think I anyhow pull out the numbers. Okay, so for hydrogen, right? Hydrogen in a compound is +1. Okay, then oxygen in a compound usually is -2, but for hydrogen peroxide, right, is a special case, it will be -1. Okay, so that means, right, the hydrogen here, okay, where's my question? Okay, here. So that means here, right, the oxidation state of the hydrogen is +1. Okay, the oxidation state of the oxygen here is -1. So +1 +1 plus -1 so balance, okay? H2O2, so +1 -1, okay? Then if we look at the water, right? Okay, if we look at here, this one, the hydrogen here is still +1, correct? But the oxygen here, right, will become -2 because H2 H2 is total is +2. So here must be -2. Okay. Right, I think here must be -2, okay? Total, this one is the total, +2. So if you look at the oxidation state, right? Someone join here. So if you look at the oxidation state, right? The oxidation state of oxygen here is -1, then it became -2 here. Okay, so that means there's a, what is it called? It's a decrease in oxidation state. Decrease in oxidation state, so it's reduction. Wait. Reduction. Wait, let me think. This one is O is -1. This one O is -2, so it's being reduced. So it should be an oxidizing agent. How could you tell that hydrogen peroxide acts as a reducing agent in reaction to from the chemical equation? It loses oxygen. Loses oxygen is reduction. I think there's a typo. Yeah, I think this is a typo. So how could you tell? Explain your answer. Okay, so okay, I will write down the answer. Okay, the answer is hydrogen peroxide is not a reducing agent in reaction to. Okay, it is not because, right, okay, one thing is you see H2O2, right, become H2O, right, it actually loses oxygen. So when you lose oxygen, right, it's actually a reduction. Okay, so if we go back to the table here, right, if you lose oxygen means it is a reduction. So if you undergo reduction, right, means you are an oxidizing agent, correct? Oxidizing agent itself is reduced. Okay, so you say hydrogen peroxide is not a reducing reagent. Sorry, it's not a reducing agent in reaction to it. Later I pull out the thing. It is an oxidizing agent. Pull it out. Okay, it is an oxidizing agent. Okay, it is an oxidizing agent because okay, so that's the answer. hydrogen peroxide is not a reducing agent. It is an oxidizing agent because hydrogen peroxide, okay, wait, let me pull out a bit. Okay, so hydrogen, so like not very good. So okay, like that better. Okay, because hydrogen peroxide loses oxygen, correct, right? Because H2O2 become H2O, so loses one oxygen. So it loses oxygen to form water in reaction 2. So hence hydrogen peroxide is reduced, which means it is an oxidizing agent. Okay, so just now I already said, yeah, this one is a bit confusing initially, but you just need to remember that oxidizing agent, right, is causes other substance to oxidize, another person, not itself. Itself is reduced. Okay, then reducing agent, same thing, it causes another thing to reduce, but it is self-oxidized. Okay, so these two very important. Student usually initially you all will get confused by this. Okay, so if it is reduced, right, means it is an oxidizing agent because it oxidizes others, self-reduce. Okay, okay, so you all can copy down the answer. For part A, right, the answer just now I show already. So, okay, I just draw here. The answer for part A is H, which I don't want to draw. H2O2. Okay, something like that. Okay. Can. Use oxygen. Let me see. Use oxygen means it's reduction. Reduction means actually wait. Let me read part C, part 1 again. Part 2 is what? Describe another distinguish between. Describe one another. How could you tell that it's a reducing region? Okay, wait, I think this one is not the correct answer. Okay, sorry, because I didn't read the front part here. Okay, so here they got mentioned, right? Okay, sorry. So H2O2, right, it's a oxidizing agent. If the oxygen is reduced to H2, that means H2O2 become H2, then it will be an oxidizing agent. If H2O2, right, is a reducing agent, its oxygen is oxidized to produce bubbles of gas that relights a glowing spin. Okay, this one, right? Relights a glowing spin, right? Means they talking about this gas is talking about this gas, they are talking about the oxygen gas. Okay, so this one is the oxygen gas. Okay, so if you look at reaction 2, right, it actually produces oxygen gas here. Okay, so it produces oxygen gas, so it will be a reducing agent. Yeah, so you cannot use the typical way of interpreting it. So so I rewrite the answer. So based on, okay, maybe so from the chemical equation of reaction 2, oxygen gas is produced as one of the products. Okay, which is the gas that would relight okay, wait, I need someone first. Okay, that would relight a glowing splint. Okay,
开始
hence
看 video 了，时间来不及了。
yeah, okay. So hence, from the chemical equation of reaction 2, oxygen gas is produced as one of the products, which is the gas that will relight a glowing splint. Okay. Hence, you write, okay, hydrogen peroxide is acting as a reducing agent in reaction 2. Okay, so I am still at the first question of the notes because just now I'm going through. Okay, so this is the answer. Okay, sorry about that. I didn't read the front part here. Okay, so this is the part A answer. The dot and cross diagram for hydrogen peroxide is on the right hand side here. Okay, then the oxidation state is +2. Okay, in MnSO4. Then this is the answer for part C, part 1. Okay, later I will repeat the so-called the notes again lah, okay, at the end of the lesson so that you all will understand. Okay, so I stay here for a while, okay. Or you can take a photo first or a screenshot, then later you copy down so can. Okay, I go to the next part first. There's one more part here. Okay, so describe one other observation that may help you to distinguish the role as a reducing agent if reaction 1 and 2 are both carried out. Okay, so we look at reaction 1 and 2, right? Oh, okay. So we look at reaction 1 and 2, right? So we see how we can distinguish. Okay. So the first one here, this one is potassium iodide. Okay, this one, okay, I write down. This one is potassium iodide. Potassium iodide. Okay, then this one is potassium manganate. So if I go back to the notes is actually your last week worksheet. Okay, so if we go back to the notes, okay, if we go back to the notes, okay, if we go back to the notes, right? Potassium manganate, it will change from purple to colorless. Then for potassium iodide, it will change from colorless to brown. Okay, so this is how you differentiate between the reaction 1 and 2. Okay, so take note, potassium manganate, purple to colorless. Potassium iodide, colorless to brown. This one is your last week notes. Okay, so you can just pull it out. Okay, this one is your last week notes. Okay, I go back. So this one is potassium iodide. So it will change from, okay, I will write down the thing here. So it will change from colorless to brown. Okay. Then for the other one, it will change from purple to colorless. Okay. So this one, they will change from purple to colorless. Okay, so this is how you differentiate between reaction 1 and 2. You see the color change. Okay, if you miss out the front part, right, you can get the recording from Miss Joy. Okay, then you can listen on your own. Okay, so describe one other observations. We just say, okay, for reaction 1, okay, for reaction 1, the color of the color would change want to say solution, does it? Is it a solution? The color of the, yeah, okay, the color of the solution would change from colorless to brown as potassium iodide is K become minus is oxidized. Okay, let me check. Is it correct? Yeah, correct. Okay. So you write from reaction 1, the color of the solution would change from colorless to brown as potassium iodide is oxidized to iodine. Okay, so this one here, the first one. Then you write for reaction 2. You write for reaction 2. Okay, the color okay as potassium manganate. Okay, 7. Okay, so this is how you differentiate between 1 and 2. So look, observe the color change. Okay, I add one more statement in front. Reaction 1 and 2 can be distinguished by the color change. Okay, so if you are done, right, you can continue on read the guided example 2 first. Question is a bit long, huh? Okay, then we will do together. Okay, can I assume everyone done? If you're not done, or later you want me to show you, just let me know. Okay, for guided example 2, okay, if you want, you can read through the whole thing. If not, I think we can straight go to the question. Okay, is the half equation 1, okay, so they're talking about the first one, is the half equation 1 an oxidation or reduction reaction? Okay, so if you look at the half equation, right, the oxidation, sorry, the electron is lost. Okay, electrons is lost in half equation 1, correct? Because the electrons appear here, so the electron is lost. So if we go back to the notes, right? Okay, I show you all where is it. If you go back to the notes here, loss of electrons, right, is talking about oxidation. Okay, loss of electron is talking about oxidation. So for oxidation is loss of electron, for reduction is gain of electron. So everything is opposite of each other. Okay, so if we go back to here, electron is lost, right? So it will be a oxidation. Okay, so another way to remember is you use the oil rig thing. The oil rig, that means OILRIG. So oxidation is lose, reduction is gain. Okay, so oxidation is loss. So we write down, okay, so this is how you write down the answer. Okay, so Okay, so that's all. Half equation 1 is an oxidation reaction as electrons are lost in this reaction. Okay. Okay, part B, part 1, right, I will just skip it lah, because dichromate is not in your syllabus anymore. This one. Last time it used to be lah, but now they only put it in the pure chem. Yeah, so dichromate don't need. So if you notice, right, just now the notes, right? Okay, wait, I show you. If you notice, right, okay, you go to the last page here. Okay, I got cross out, then I got tick lah. Cross out means you don't need to know. Okay, tick means you need to know. Okay, or highlighted means you need to know lah. Okay, cross out means you don't need to know. Okay, because these two is in pure chem syllabus, but for combined chem, right, only the second one, the acidified potassium manganate. Okay, so for this part, I will just skip. Okay, this part I will skip. Okay. Okay, this one I skip everything first. Okay, I skip the whole question already. The rest not very important. Yeah. Okay, then we go to the workbook. I think you all don't have the hard copy, right? Okay, next one I'll pass you all. Okay, yeah, let me go back to. Okay. Okay, this one we will do together. Okay, y'all can take down the question first. I need to charge my laptop a while. So give me 1 minute. Okay, y'all can copy down the question first, then later I will go through. Just copy down the equation. Okay, on the foolscap first. Okay, so charge already. Okay, you all copy down already. Okay, then I zoom in. Okay, here they say explain your answer in terms of gaining, losing of oxygen / hydrogen. Gaining or losing of oxygen / hydrogen. Okay, so they say which one is being oxidized. Okay, so right, you look at the, okay, you look at here. Okay, I need to use my pen. Okay, from here to here, right? Okay, from this one to this one, right? Very obvious, right? This one is loss of oxygen, correct? Okay, then from here to here, right? This one is loss of hydrogen. Because NH3 must become N2, so no more hydrogen. Okay, so this one is loss of hydrogen, this one is loss of oxygen. Okay, if we go back to the notes, right? Okay, because if not later I say then you all don't understand. If we go back to the notes, the page, this one, okay. So for oxidation, right, it must be gain of oxygen or loss of hydrogen, either one. Then for reduction will be the opposite, loss of oxygen or gain of hydrogen. So in this question, right, they want state which one is being oxidized, right? So it's either gain of oxygen or loss of hydrogen. So if you see loss of hydrogen, right, will be NH3, okay? So how you write is, okay, I write at the side here. Okay, NH3 is oxidized. as it loses hydrogen to form N2. Okay, you need to subscript all these. How do I subscript? Okay, they don't let me subscript, so you all get what I mean. Huh? That means you write NH3. Okay, I write at the top NH3 like that. Okay, then N2. Okay. Okay, so that's all for the first one. Okay, then we do the same thing for the other question. Okay, so F2, this one gain, right? This one gain H. Okay, I just put H lah. I don't spell out hydrogen. Then this one lose H. Lose H. Correct. The F gain H. The H2O lose the H, become O2. So for oxidation, right, oxidize, it must be loose of hydrogen. So the one that loses hydrogen will be your H2O. So you write down, okay, so now you type out. So I type out, you write down, okay. H2O is oxidized, okay, as it loses hydrogen to form O2. Okay, so same thing, remember to subscript. Okay, so H2O, O2. Okay, actually not very difficult, right? It's still okay, right? Just need to memorize. Okay, then the other one is, this one is, okay, lose oxygen, correct? Because ZNO becomes ZN, so lose oxygen. This one is gain oxygen, because CO becomes CO2, so gain oxygen. So for oxidation, right, it will be gain oxygen or lose hydrogen. So the one that gain oxygen, right, will be the one that oxidized. So in this case will be, okay, so you write CO is oxidized, okay, as it gains oxygen to form CO2. Okay, CO2. Okay, so that's all. Okay, then I go to the next page in a while, another 10 seconds. Okay, so next page. Okay, for this one, it will form green chromium oxide, nitrogen and water. Okay, this one I will balance for you all. Okay, so just write down. Give me a while. Actually, there's a typo here. This one should be NH42Cr2O7. Okay. Okay. Then they say it will become chromium 3 oxide. So it's Cr2O3. Okay. Chromium, yeah, chromium 3 oxide. Yeah, correct. Then plus nitrogen plus water. Okay. Then you need to balance. Okay, so let's balance this. This one should be 4. Here should be 4. That's all. Okay, so this will be the balance chemical equation. Okay, then they ask, okay, is the chromium in the crystal oxidized or reduced? Explain in terms of oxidation state. Okay, so for the chromium, right? Okay, we focus on this one first. This one is chromium 3 oxide. So for chromium, right, this one I think I got explained before. If there's a 3 means the chromium will be 3 plus. Okay, the charge. So here the chromium here, the oxidation state, right? I put OS, okay? Oxidation state of chromium here is +3. Okay, it will be equivalent to the charge. Okay, just now I went through in the notes already. So oxidation state of chromium here, sorry, not CS, it's CR. Okay, oxidation state of chromium here is +3. Okay, then we look over to this side, right? Okay, this side a bit challenging. Okay, this one is, this whole thing here, okay, is Cr2O7. The charge here is 2 minus. Okay. Here, oxygen on its own is -2, so -14, so -14 +12, so +6. Okay, you all just take it as it is, okay? The oxidation state of chromium here, right, is +6. Okay? The oxidation state of chromium here is +6. Because each oxygen, right, each oxygen is -2, so you got 7 of it, so is -14. Then in order for the overall charge to be -2, right, here must be +12. So you divide by 2, so it's +6. Okay, so okay, I highlight the important thing. The important thing is, okay, I use another color. The oxidation state of chromium is +6 here. Okay, then the oxidation state of chromium at the product, right, is +3. Okay, how to determine, right? You go refer to the notes. Okay, those that miss out the front part, right? You ask for the recording. Okay, later I will mention a bit of it. Okay, so go back. Okay, so is chromium in the crystal oxidized or reduced? Okay, I type out first, then I explain. Okay, chromium okay, why is it reduced, right? It's because, okay, say, let me bracket first. Okay, chromium in the crystals is reduced as the oxidation state of chromium is reduced from +6 in H4 to CR2O7 to +3 in CR2O3. Okay, so this one just rewrite it as the correct way. Okay, so you write NH4 to CR2O7. Then this one is CR2O3. Just that I type, I cannot subscript. Okay, so right, for oxidation state, right, okay, later I come back, I show you all the notes first. So for, you see, for oxidation, right, it will be the increase in oxidation state. For reduction is the decrease in oxidation state. So if you go back, okay, +6, right, become +3. So this one is reduced, the oxidation state is reduced. So it will be reduction, okay, so reduced. Okay. Okay, so let you all copy down first. Okay, oh yeah, then for those that join the Zoom meeting late, right? What Miss Joy say? Let me see. Just now she text me. Okay, she say she will give you all the link to watch the front part of the lesson. it will be available on Monday onwards. So it will be available from Monday onwards. Can? Okay, so the link to the Zoom lesson. I think there will be a few Zoom links because just now I got kicked out by the Zoom. Okay. Because they will record like once I start the lesson, so they will record. I don't know how they do it also. It's not record until my computer. It's record on like some, what is it called? Like the cloud, iCloud, something like iCloud. It will straight away record, then make it as a Zoom link or something. Okay, so enough of the talking. Question 2 done. Yeah, let me see. Okay, we cannot avoid this. Okay, let's write down the ionic equation. Okay, for ionic equation, right? Okay, I show you how to write down ionic equation first. So, okay, those that are equal state, right? You need to split the ions up first. So, okay, so write down the working. So write Pb 2 plus okay, I no space, so I write here. Okay, so you split the equal state one, right? So you look at all those with equal state one. Okay, this one with equal state one, right? You split into the ions. Okay, then what you do, right, is you need to cancel out the so-called the spectator ions, you know, like spectator. Okay, so you cancel out the spectator ion. Then the remaining one, right, will be your ionic equation already. So the final ionic equation will be Pb2 plus, okay, equals, okay, plus Mg solid will become Pb solid, okay, plus Mg2 plus equals, yeah, so this will be the answer. Okay. Only those with equal state, then you split the ions up. Okay, for solid, liquid, gas, right, don't need to split. Okay, so if we look at the ionic equation, right, okay, Pb2 plus become Pb. So this one to this one, right, from positive 2 charge becomes 0, right? That means this one is gain electrons, correct? Okay, then from magnesium solid become magnesium 2 plus. This one is lose electrons. All right, because you become more positive, means you lose electrons. Okay, so which substance is oxidized? So we go back to the oil rig thing. Remember the oil rig? Okay, so which one is oxidized, right? Oxidized means oxidation is lose. Okay, oxidation is lose electrons. So which substance is oxidized? So the answer is magnesium. Okay, so we write down. Anyway, the oil rig thing, right, is only for electron, this one. For oxygen is opposite. Okay, so let's write down. Okay, which substance is oxidized? So you write magnesium, Mg solid is oxidized. Okay, then you say as it loses 2 electrons to form Mg2 plus equals. Yeah, this one you help me rewrite a bit. This one it should be like the Mg. Yeah. Okay, then we continue to the next one. Yeah, okay. For each of the reaction, give the formula of the substance which is oxidized and which is reduced. Explain in terms of oxidation state. Okay, for oxidation reduction, right, usually they will tell you like explain in terms of what. So just now, this one is they say explain in terms of electron. Then here you say this one is explain in terms of oxidation state. Okay lah, okay. Okay. I think I finished this question, then I can end for today already, because oxidation state is a bit hard to understand, okay, but because just now I went through already. So for this kind of element, right, like Cl2 element, right, the oxidation state is 0. Okay, just take note, the oxidation state is 0. Okay, then for chlorine here, right, you see here, this one is chlorine ion, right? This one will be the ion charge itself, so it's -1. Okay, so this one is from 0 to -1. So this one is decrease in oxidation state. Okay, so this one will be the reduction. So you write down, okay, so you write down Cl2 is reduced. Okay, then you say as the oxidation state of Cl in Cl2 is as the oxidation state of Cl decreased from 0 in Cl2 to -1 in Cl minus. Okay, help me do the subscript thing. Okay, so okay, I will write down also. This one change to Cl2. Cl decrease from Cl2 to Cl minus like that. Okay. Okay, then you need to see which one is oxidized, right? Okay, the one that oxidized most likely is SO2 lah. Okay, so for oxygen, right, the oxidation state by default is -2. Okay, so you go to the notes, you will be able to see it. The oxidation state of oxygen by default, okay, usually is -2. So here got 2 oxygen, so it's -4. So that means the sulfur here, right, will be +4. Okay, the sulfur here will be +4. Then we look over to this side, right? Here there is 4 oxygen, so total is -8. Okay, each of it is -2, total is -8. But in order for the overall charge to be 2 minus, right, here will be +6. So the sulfur here will be +6. Okay, so this one is +4, right? Become +6. So this one is increase in oxidation state. Okay, so this one will be the oxidation one. So we type, okay, so SO2 is oxidized as the oxidation state of sulfur S is increased from +4 in SO2 to +6 in SO4 2 minus. Okay, I write down in pen. Okay, so you write SO2, SO2, SO4 2 minus. Okay, whenever we talk about oxidation state, right, we are talking about the oxidation state of the element itself. So you can see how I write the answer. I will say oxidation state of sulfur. oxidation state of chlorine. Okay, we don't talk about the compound, but when we talk about oxidized, reduce, right? Then we talk about the compound. We will say that, okay, this whole compound is oxidized, this whole compound is reduced. Then another thing to take note is the charge, right? The oxidation state, usually we put the sign first. That means we put positive, negative, then we put the number. It's a bit different from the how we write in here. We'll write 2 minus here, right? Here we will write -2. Okay, instead of 2 minus, something like that. Can okay. I do one more. I do here. Okay, so for I will do the next part. If you're done, you just look at the next part. So for aluminium, right, because it is on its own element. Sorry, I accidentally pressed something. Okay, go back. Okay, here. So for aluminium, right, it is on its own. Okay, the aluminium here is on its own. So the oxidation state of aluminium here will be 0. Okay. Then here, right, this one is Al, aluminium oxide. This one is a ion already, so it's +3 because it's in group 3. Okay, so it's +3. So this one, the chromium is on its own, so it's also 0. Okay, this one is 0. And this one here, oxygen, chromium 2 oxygen, so it's almost the same. So here is also +3. Okay. Because oxygen by default is -2, so 3 of it is -6. So you divide by 2, +6 divided by 2, so +3. Okay. So this one is decrease, right? Decrease. This one is increase. Okay. So oxidation will be the aluminium. So you write, okay, so we type out, okay, Al, okay, Al is oxidized. Yes, okay, as the oxidation state. You see the way I answer it, right, is very, very boring one. It's always the same. The oxidation state of aluminium is increased from 0, and you must tell them in which compound. So you see 0 in aluminium to +3 in Al2O3. Okay, can I don't write the subscript down? You all get what I mean, right? This one, just write Al2O3. Follow the chemical equation. Okay, then for reduction, same thing. You write Cr2O3 is reduced as the oxidation state. Sorry, this one I forget to write oxidation state. Oxidation state, yeah. As the oxidation state of chromium is decreased, okay, from +3 in Cr2O3 to 0 in Cr. Okay, I adjust now. Whenever we answer it, right, we always talk about the reactant. We will say aluminium is oxidized, chromium oxide is reduced. We don't talk about the product. The product we only talk when we're talking about the oxidation state in where and where. Can. Next week we will do more of it, so don't worry. Okay, we do the last one, then we end for today. I want to finish this one. Okay, so same thing. Okay, for sodium on its own, right? So oxidation state is 0. Hydrogen on its own, oxidation state 0. Okay. Okay, this one I give you. This one is +1. The hydrogen here is +1. Then the sodium here is also +1. Okay, so this one is increase. This one is, sorry, label wrong. This one is decrease. Okay, so increase one is oxidation. So you write, okay, so now we type, you write, I type, okay. So sodium is oxidized. Okay, this one, right, can you help me change something? I just realized something is wrong. Here, right, this one shouldn't have the H here. Can you help me cancel the H here? There shouldn't be a H. There should be C2H5COONA. Okay. Then help me subscript the answer also. Then for the reduction one, then you write C2H5COOH is reduced as the oxidation rate of H is decreased from +1 in C2H5COOH to 0 in H2. Okay. Can you help me remember help me subscript C2H5COOH. Follow the chemical equation. Can? Okay, then the rest, right? Next week I will continue for next week. Okay, not much question left. Okay, so for the notes for redox reaction, right? The notes for this chapter, okay, it's actually at the back of the. Remember last week we talked about the exo endo, then we talked about the speed of reaction. The redox notes is actually at the back here, so you all can go read it through. Okay, just now I went through a bit already, so yeah, so you all will go and read through this part. Can? Okay, if no question, you all can leave the meeting. I will see you all next week at the center for those that are physical one. Okay. Okay, I will stay here for a while. So if you got question, you can type in the chat. Bye bye.